This meeting is being recorded.
Hello, good morning, everyone. We will begin shortly. Okay, let's get this started. I see attendees just trickling in, but I will just do the quick introduction. Welcome, good morning. Hello, everyone. Welcome to this technical webinar on a new framework, Global Economic Disruption Index, or as we call it GEDI, for assessing the economic impacts of climate change and disasters. I'm Shubhra Ghosh from ImageCat, and I will be your moderator today. GEDI is a NASA, GEO, Google-funded modeling framework that characterizes the broad economic impacts of disasters, including economic restoration and critical infrastructure recovery time. GEDI challenges the traditional catastrophe modeling approaches and provides a simple index for widespread use for government, insurance, and nonprofits to make decisions about disaster resilience. Today, we have an extraordinary set of individuals to speak on this research topic. We will start off with Dr. Shana McLean, who is the Disasters Program Manager for NASA's Earth Science Applied Sciences Program. She also manages Earth Sciences Global Partnerships and is the manager for Socioeconomic Assessment Portfolio. Shana and her team promote the use of Earth observations to support decisions for societal benefit through informed disaster management. We also have today Charles Hike, who's a colleague and collaborator. He is a founding partner and executive vice president of ImageCat. He directs a team of engineers, scientists, and programmers developing software tools and novel analytical methods to assess risk. We also have Diana Chow. She is one of our collaborator and partner from Kinetic Analysis Corporation. She's the operations lead and natural hazards analyst at Kinetic. Diana graduated with honors from Princeton University with a degree in geosciences and with a minor in history and the practice of diplomacy, specializing in climate and atmospheric sciences and their human impacts. Our speakers today will discuss the NASA Disasters Program, the goals and objectives, current activities and future direction, and of course, the application of the GEDI framework. Today's webinar has been recorded, and we will be sending out the link to all registered attendees. We will be covering the questions at the end of the speakers, after the speakers finish their talk, and we will go from there. So with that, I would like to turn over the floor to Shana. So Shana, I'm going to stop sharing my screen here. If you could take on from here.
Great, thank you very much, Shubhra. Hi, everyone. Hopefully you can see my screen and we are all set to go. So as Shubhra just introduced, I'm Shana McLean. I manage the NASA Disasters Program within the Earth Sciences Division of NASA. And it's a real pleasure to be able to join this webinar today. So I'm going to talk briefly about the Disasters Program and some of the key elements that contribute to my overall vision for the program, which includes creating an inclusive and interdisciplinary program that can better understand the complexities of human and environmental interactions. Some of these, of course, lead to disasters and crises, but this requires, I think, a lot of advancement in a number of ways. One, in how we understand social, economic, and physical factors that increase exposure and vulnerability. It also involves advancing our focus to include current and future impacts from disasters, such as changes to livelihoods, disaster displacement, migration, et cetera. And also better integrating climate change into how we model future disaster impacts so we can build more resilient and climate smart communities. But essentially, my program is built into 3 pillars of work. The first is focused on disaster applications, and this is specifically developing and advancing information and technology that helps us better understand hazards, exposure, and vulnerability, and translates this into better, hopefully, into better decisions related to disaster management. So many of you likely know NASA is a grant-making institution, and so in this pillar in particular, we're directing disaster-focused applications to be developed in order to answer the gaps that either we're seeing around the world or that we're learning from our partners that are working in different fields across disaster management. The second pillar of the disasters program is focused on providing technical support, data product development, and integration for active disasters. And this is our disaster response coordination pillar. So we develop products and tools and other capabilities to support the operational decisions and response efforts of our partner. And so we have an active team working across multiple NASA centers, leveraging all of the science and technology across NASA to be able to support those working on the ground during an active crisis. And the final pillar of the program is focused on partnership engagement and supporting open science. And so in this field, we work with domestic and international entities, private and public institutions, to build their access and capacity for using the work that our program does to facilitate disaster management needs. We also facilitate open science by hosting and developing a disasters portal that essentially, I would say, it hosts or curates the variety of products and tools that are developed across the program and makes them available to partners in a few different ways. One is by developing story maps and different ways of providing a narrative to explain, what the core components of a disaster are. What are the things that we need to look at when we're considering an active disaster? What are some of the earth science information capabilities that are available to unpack those components? But we also provide the data and data products that are available in GIS format for stakeholders to be able to integrate and pull from into their existing capabilities. And at this point, I'm really going to focus on the first pillar of disaster applications to explain why I'm excited by the work being developed by Charlie and his colleagues, and what we're going to be discussing later on. And so within our disaster applications portfolio, we host a number of risk-based activities looking across multiple hazards to improve the understanding of these hazards and the susceptibility of communities to these risks. There are 10 different teams working around the world to better integrate earth science information into operational decisions of partners on a variety of hazards that are reflected here. And so these run the gamut clearly from floods, landslides, volcanic ash, to fire behavior, smoke, hailstorms, improved tsunami warning and oil spill monitoring. But we also have specific projects that are assessing damage and impact to critical infrastructure and to economies. And this is where I think I'm trying to focus, since this is the overarching topic today. And so while there's a lot being done, I think, around the world to expand our understanding of risk, there remains this overarching question in my mind of why we're still seeing such a loss of lives and livelihoods to disasters. And much of this is due to our limitations relating to connecting the social and economic vulnerabilities into our assessment of hazard susceptibility and risk. So I think in some cases, the complexity of threats and the integrated planning required to build resilience is overlooked in programming. So the connectivity among sectors is ignored. For example, we're failing to connect the drivers of instability or fragility and how these drivers are related, like disasters, how disasters can, close roads, lead to eventual market closure, reduce access to food, leading to insecurity in jobs and in health, possibly driving migration to other regions. So what is that? The connectivity among sectors, what does that look like, and how can we better consider it when we look at risk reduction and resilience? In other cases, I think it's overlooked that a wide range of solutions are needed to address vulnerabilities to specific types of disasters. So a single type of disaster, such as flooding, can not only mobilize pollutants, creating health impacts, which activates the health sector, but it can flood agricultural areas, leading to food insecurity. Of course, that's the ag sector, while also damaging homes and businesses in ways that impact lives and livelihoods. So there's a multi-sector component, but there's the flip side of the vulnerability in the people who are being impacted. And finally, communities are often excluded from all of the planning decisions that go on across these processes. And this can remove critical information that's happening at the local level, leading to not only exacerbated marginalization, because we're not giving people agency or a voice over what is happening within their own communities, but also we're increasing their vulnerabilities by not characterizing the risks appropriately. And so finally, this just brings me to the fact that given all of this, I think it's critical to not only advance our capabilities in climate services, environmental security, and in early warning and anticipatory action related activities across multiple hazards. But if we're really going to make a difference in moving from risk to resilience, we need to better integrate perspectives on vulnerability and environmental justice into our disaster management processes. And so integrating issues related to the human condition, to policy decisions and governance into our approaches for mapping risk. I mean, I think it'll be difficult and require possibly highly nuanced approaches and interdisciplinary teams, but it's a step in the right direction for building more resilient communities. And frankly, I would say that the work presented here today is one example of such a step in the right direction. And so I look forward to hearing more from Charlie and Diana, and I'm going to stop here and thank you all for your time.
Thanks, Shana. Thanks for the introduction and putting Charlie's talk in context. So while we wait for Charlie to share his screen, just a quick note here. If you have any questions, since this is a webinar format, we are encouraging questions, but use the Q&A box and I will present the questions to the speakers. So Charlie, if you...
Yeah, Shane, I think you need to stop sharing your screen there before I can share mine.
Okay, there you go.
Here we go.
My apologies. Hopefully it's stopped.
Yeah, no problem. All right, thanks for that, Shana. We couldn't have done it without the disasters program. This work was funded by NASA. The group on Earth observations did work with Google to get us a license to Google Earth observations. I'm sorry, to the Google Earth Engine platform. But over the years, NASA has been a big supporter of our research in a way that's quite exciting. Most of the research into EO and disasters has to do with damage detection, or at least detection of the hazard footprint. And we've gone into trying to characterize the exposure databases, infrastructure in new and exciting ways that NASA was able to really see that vision. And I really don't think that others would have jumped on board and funded such research. So I'm going to be presenting the Global Economic Disruption Index, as Shubhrup said. We are also here partners with CSUN at Columbia University in this research. And quick overview of the problem. Most of you are probably familiar, but with CAV models, they tend to do a pretty good job of detecting what, or predicting what the direct damage would be, what the losses would be for building damage. But when you've got huge events, that's a very small part of the damage, right? Because you have massive amounts of disruption, has economic consequences in ways that make it so that economies can't rebound effectively. It basically gets in the way of rebounding. And the poster child for this here is the floods in Bangkok in 2011, where widely publicized, The GDP of Thailand shrank by almost 11% the following year because of the flow of flash drives, automobile parts could not come out of Bangkok. And if you look at it, there's not that many buildings that flooded, right? Very small number of buildings flooded, but the rippling economic effects were huge. And if you look at these massive events with indirect economic effects, they tend to come down to either manufacturing or critical infrastructure disruption. So looking at that problem in a little more detail, as probably many of us on this call have, it's a very complicated problem, right? You've got a lot of these systems that are feed into the ability to make goods and services and make a city run. You've got power, water, the supply chain, flow of goods and services, transportation, actual building damage obviously impedes production. And then you've got politics and aid that come into the equation. And on top of that, you've got another layer of sort of interconnectivity and resilience of those systems. So each of these systems are going to be built to different specifications. Each component in each of those systems are going to be built to different specifications. They're going to be interconnected. It means you have to kind of understand how water affects power, power affects water, and the interdependency of these system flows are dependent upon each other. And you've got vulnerability, right? How well these things are built, when were they built? So it's a pretty hard exposure problem. And those of us who've done work in this area know that, if you're doing work for LA County or something, and you've got everybody coming to the table with data sets, you've got security concerns addressed, you might be able to do some pretty good work. But if you're trying to do something globally and you're trying to put together exposure data sets, the uncertainty on things like interconnectivity, resilience, vulnerability quickly overwhelms your ability to do any modeling, and fortunately you just get noise. So in true NASA spirit, we've got a moonshot here to try to see if we could solve this with EO data. And the question that we've asked ourselves is, can EO be used to characterize potential for this long-term economic disruption, or find these accidents waiting to happen, as we pitched it to NASA? And we start from the premise that disasters essentially have a tipping point. The demonstrated resilience of an economy really depends on the magnitude of the event and the impact. And there's a tipping point where, if you try to predict how economies will change, how they'll react, they tend to perform better than you'd expect in ways that, reflect people helping their neighbor, the effectiveness of government aid, people working overtime, et cetera, until the damage to specific systems starts to impede the ability to bounce back. And that's where you start to have these cascading failures where, you can't get goods in because of transportation, for example, or, you can't get a manufacturing basis up and people have to start to migrate out of an area. And those kind of cascading effects is really where you have a lot of the damage in the very large events. So that's the kind of premise that we're starting about, that there's correlation, if you will, between the magnitude of the impact to that critical infrastructure and supply chain issue, and how well the demonstrated resilience will be. So from technical standpoint, we start from something very simple, right? Here is Bangkok. You can see the areas of manufacturing and critical infrastructure. There are these sort of areas in white here on the outskirts of town. You can detect it with segmentation algorithms, standard EO practice. You can overlay that with flood data and identify areas that are problematic. And then you can make decisions about impeding the production of those areas that you have in economic databases. And as you impede the flow of goods and services out of those areas, you can stick that into economic modeling to be able to get a financial indication of the impact. So we demonstrated this in an India pilot for three kind of paradigms of disaster modeling, if you will. Probabilistic flood modeling, which we did with our partners at JBA. They gifted us quite nicely the 100 your flood data that we had in the enhanced platform, and we demonstrated that these are the areas where you would effectively have the most disruption given a 100-year flood in that county or Adam level 3 area. Impending events, actual real-time events. This was working with our pals at Kinetic. Diana will be speaking next. She's from Kinetic, doing real-time analysis and saying, okay, what can you expect if a typhoon comes to shore? And then a climate condition scenario. We did this one ourselves, looking at sea level rise databases, periodic flooding, what you'd expect for RCP 8.5, where you might have the most economic disruption, and Mumbai comes out as a highlight there. So the problem here was, we didn't have much validation, except for in the typhoon. Looks like, according to the India Times, we did an okay job there. It did seem to correlate with what we were finding. But people came back. It was exciting. We could do it. We got our rocket built, so to speak. But people came back and said, okay, what do these colors mean? How can we use them directly? And how good is it? How do you have any validation data here? Which were quite good points. So we kind of went back to the drawing board a little bit and developed a scale, a simple scale that we envisioned, but it was almost like the modified Mercalli scale for earthquakes, or the Saffir-Simpson scale for hurricanes, where it's something that might that you might have along with the impact of an event that you'd be able to use to make subsequent decisions. And it's 1 to 5, slight to catastrophic. And just real simply, I like to think of it as like hours to days for slight, days to week, moderate, on the order of weeks, less than a month for major, months for severe, and then years or maybe even recovering to a new normal for catastrophic. And then we have a much kind of longer description that we use to talk about things that we might expect for the critical infrastructure. So we put together this scale, and our friends at Kinetic gave us their history going back, I think, to the 80s of actual hazard data. We put that into our Google Earth Engine platform to come up with a JEDI scale. We used the data this century to see how to train the data and then see how good we did on the previous century, and we did very good, which was quite exciting. In all instances, we were kind of within one of the rank that we had an independent group come up with the actual rank, and the observed rank, it's a little bit a matter of opinion, trying to go through those historic records and figure out what the actual restoration of was not easy, but essentially we were able to do as good as the historic record. We would have started with earthquakes. We kind of earthquake folks, but we had there's not that many earthquakes, but we did have the Northridge earthquake, where I started my career there in Northridge, putting together this report with my partner Ron Aguchi. So we said, hey Ron, what was Northridge? And he came up with the answer between 2 and 3. So there is no between 2 and 3. There's only 2 or 3, but we ran it through the system, and yesterday got the answer of 3, or 2.75. So a low 3. And if you look at the event, that's about right. As a matter of fact, I think that's probably what we were thinking of when we thought of a major event. Restoration, the economy rebounded on the order of weeks, essentially, with some dire consequences to vulnerable small businesses, which has been well documented in the Valley. Primarily effect was on the local economy. It wasn't ripples throughout the global or national economy. And you had, disruption to the water supply and fuel supply that was on the order of 3 weeks, I think it was, for water supply, having mapped it 25 years ago. So we put together the scale. We sort of established that it could work. We've gone out and we've showed it to insurers, brokers, NGOs, governments, and we've come up with sort of 5 categories of use cases. And I'm presenting them all because I think that even the ones that are tailored towards commercial applications, I think do have either they're government bodies that are really kind of mandating and pushing forward some of this stuff, or they do have application for government as well. And the first one I think is probably the most obvious, building off of the work with Kinetic. You've got applications like PDC's disaster aware. You've got NOAA advisories from the National Weather Service that are heeded quite widely. You've got a Shitcast, a Kineticast. All these programs tell you what it's likely to expect. Generally talking about the hazard or having some direct consequences. We feel that being able to pair that with a JEDI score to communicate to the general populace and responders what the potential cascading economic impact could be would help with mobilizing resources and be useful information for businesses trying to make decisions whether to get their airplanes out of the way or all the other things that they have to do. The second one I think is probably pretty obvious. We touched on it as we went through, and that is really identify accidents waiting to happen. This is a macro level analysis. I don't know what's in. I do know what's in Mumbai because I had to look and validate the data, but I don't know the vulnerability of the system. So using this to identify where there might be accidents waiting to happen and do further research into the specific elements that are there and at risk. In order to prioritize infrastructure projects or to model unmodeled hazards. It's a buzzword in insurance and around Lloyd's unmodeled hazards. Where's the next huge thing that we didn't anticipate, so that you can actually mobilize insurance to those areas or develop parametric products. We've also had discussions about developing parametric insurance products off of these scores, or at least using them to help businesses figure out where they need to have parametric insurance to cover threats to the supply chain. Use case number 3 is regulatory disclosure at ESG. And this is one of the first exciting things that came out of it that I didn't anticipate personally. But what's been happening with TCFD and now SEC has got a proposal out there is that governing bodies and some of them are mandated, some of them are voluntary, but the SEC one, it looks like it's going to be mandatory, are asking businesses to get a handle on the threats to their businesses and to their supply chains and to their suppliers of climate change. And this is a very easy application to do that. We're kind of hazard agnostic, so long as we've got a disaster, a damage function that we can put in there. Tied to a given excitation, we can take somebody else's opinion as to what's going to happen in the future and then run that through our model. So you can see, there might be, huge international corporations might just know we've got mining in China, high tech in China. They don't have any idea where the risk is, or specifically where those sites are, what the risk is, or what those dependencies are. But those are all stored in economic databases that can be that you can drill down on. So we can take that information, and the information that's used to come up with the JEDI score actually has a hazard ranked by sector and by higher unit of geography. That's why you've got these red, orange, green blobs here. So that you can use that to have a weighted risk for those areas for any kind of future hazard that you have. So you can envision a system where companies would come with their exposure by sector, by country, by state, whatever they had it in terms of geography, load it into a platform like Enhance and be able to get those ranks back, which basically disaggregates their risk and gives them a score that they can use to fulfill the SEC and the TCFD requirement. It's acknowledged by TCFD that you're going to have to drill down to both qualitative and quantitative information in a way to be able to report that, because of the challenges. People are scrambling to figure out how to get this information. This is a real simple application that can get people started. So excited about that application. Use case number 4 is actually already in operation, where we are in business doing this today. this came out of the JEDI platform. That is, our commercial real estate clients recognize that the risk to their investments don't come just at the building level. An example I like to use is this this building that is from a FEMA success story. They built quite cleverly tuck under parking on the first layer, which was a little higher. The storm surge from Katrina went right through. They were able to set back up right away. But the neighborhood was decimated, right? Going on for over a decade. You started to have blight. You started to have little camper van communities pop up. It wasn't an area where you'd want to buy a condo or go visit the beach. So it's recognize that you have these kind of situations, or the famous picture of the people that decided to build way above the base flood elevation, and the neighborhood's wiped out, right? How are you going to even get there? So mitigation has to be thought of on the neighborhood in order to assure resilience. Getting back to some of the ideas that Shana was talking about. So what we've done is we've used the JEDI program with different hazard data sets to come up with these risk regional resilience assessments by the MSA level for each of those hazards now and in the future. And we are giving that to commercial real estate investors so that they can report back to their board what they're doing and what their scores are, and then use that actually to prioritize acquisitions in the future, because it's widely recognized that if that as you start to get a better understanding of risk, that's going to affect the investment, even if you are able to ignore that risk today. If you've got risk from climate change, they're going to want to know, because in 5 years, someone's going to know and not going to want to pay as much for that property. So commercial real estate investors are really, I think, at the forefront of being able to understand this resilience problem. And JEDI has really folds right into that decision-making process. Case number 5 is a pretty interesting one. It combines a few things, so try to roll with me here. It started with the idea of, trying to address equity. We have a sort of club, if you will, coming out of the MMC NIBS project, the 4-to-1 project, where we started to look at the cost effectiveness of different mitigation efforts. That group has really started to look at the issue of equity, and particularly as it relates to benefit cost analysis. Because benefit cost analysis does not really consider indirect economic effects effectively. So we started to do some experiments using CAP models, supplemented with a JEDI framework in a way that we think could actually be used to take a better look at equity and get better, more accurate benefit cost analysis scores to prioritize mitigation that starts to get to this this neighborhood resilience issue. So here's the actual research that was really led by Yaji Lee in our group, our Seismicat group. We had some data not only from the NASA project, but from some work that we were doing from ATC, Lifelines. So if you look at this work was all done in Los Angeles County. And if you look at different populations, how the earthquake risk affects different populations on average, that means in any given year, and the economic loss that you'd expect per household between the entire population, census tracts that are primarily Black, primarily Hispanic, or primarily low income, it all looks about the same. There's a little bump here, the African American community, looks like they might actually have a little less risk. But if you look at the 475-year event specifically, that is not all these small events that just shake and do a little bit of damage, but where you start to have these cascading effects, the Black community starts to balloon out there. You get they have this bump at $50,000 of building loss per household. That start to have a much greater percentage there, or $20,000 more per household. And if you go to the 2475-year event, then you have a much stronger trend. And that's because of the Inglewood fault affecting Inglewood and a lot of South Central. But if you look just at the average annualized effect, you don't see that. So trying to marry the looking at equity with a probabilistic framework allows you to sort of find these accidents waiting to happen. And once you find those accidents waiting to happen, you can correlate them with things like the JEDI score that allows you to start to quantify those indirect economic impacts in a way that that is more suitable for benefit cost analysis. So social scientists are able to say things like, well, you know, on average, if you've got this much damage to your house, you know, it's going to cause this much PTSD, this much you're going to have to go relocate to a hotel. That's all analyzed on a building specific level. At least it has been historically. But if you move to a probabilistic framework and start to integrate this JEDI score that looks at a per event disruption index, then you can say, well, the PTSD is going to be much greater for this 2475-year event. Obviously it is. You know, it's going to recover to a new normal. It's going to take years to recover. People are going to have to move. You know, so being able to quantify that will make a much stronger case for addressing the equity issues and mitigating neighborhoods that are much more vulnerable to these cascading effects. So this is another area that we're quite excited about moving with the JEDI score. And that's what I got. Shubhru.
Thank you, Charlie. Thanks for the exciting presentation and covering the various use cases. We'll come back to questions. You know, please type in your questions in the Q&A box at the bottom of your screen. So Diana, you're up next. Please begin your presentation. Diana, you're muted.
Yeah, I know. I was, yeah, don't worry. I got you. Okay. So thank you so much, Charlie, for that, and also Shanna for that wonderful introduction to why it is that we are caring so much about these disasters and what we can do to prepare for them. So I'm going to talk a little bit about KineticCast, which is a collaboration between MHCAT and the company I work for, Kinetic Analysis Corporation. So who is Kinetic? Well, we go by KAC. We've worked with a number of folks in the past who I think can basically demonstrate just how much we're all in the same space of really trying to figure out how best to approach climate disasters. And that's why with the help of MHCAT, we created KineticCast, an applied forecasting tool. So here's a summary of the sort of data we try to generate within our work. So for example, we have real-time tropical cyclone hazards data looking at maximum winds, storm surge inundation, significant wave height, and cumulative rainfall. Real-time earthquake ground motion data, including all sorts of different types of metrics, hazards from wildfires, historical catalogs, and economic and facility impacts. So all of this can be used as input for things like JEDI, as Charlie showed earlier, but you might be curious about what we do with those in that forecasting tool I was talking about previously. So I want to show you a little bit of KineticCast in a live state. These are screenshots from when things were live back on July 28th, 2022, and I think it'll make a lot more sense. So for example, when you head to the KineticCast webpage, you're greeted with a look at the current active storms and some basic but important information in table form about each storm. And then you can hover over any storm to look at it in more detail. And once you click on it, you get transported over to an interactive console where you can see that storm in far more detail. So to generate these results, we take input from agency forecasts or model guidances and run our in-house atmospheric and oceanic models. And the results are being updated on KineticCast for real-time storms, usually within 30 minutes of any new forecast information becoming available. So here's what that sort of first interactive console looks like for each of the 3 active storms at the time that these screenshots were taken. Now, of course, some data is going to be toggled off by default since we don't want to overwhelm anybody, but you can toggle those layers on and off. So here I've switched on the multi-model tracks to show forecasts from a variety of agencies and model guidances. And now I've turned on the cone of uncertainty layer as well. So the cone of uncertainty is based on forecast statistics from the past 5 years. So while it might be useful, it's not specific to the storm itself. So instead, we use it as a sort of qualitative gauge on uncertainty. So for example, if you combine it with these multi-model spaghetti plots, you can see if maybe all those tracks fall within that cone of uncertainty, or maybe the tracks are all over the place, and that gives you an idea. So you can also change the hazard of interest. So earlier we looked at maximum winds. Now I've switched on over to storm surge inundation. You'll see that the legend on the right has updated accordingly as well. Now this was generated due to our models capturing the response of the ocean to the changes in atmospheric pressure. So a 1 millibar change in atmospheric pressure results in about a 1 centimeter change in sea level. And the forecast for Frank at the time showed pressure dropping to about 970, which could cause the sea level to rise by just over 1 foot. So our storm surge over land accounts for these things, and it also accounts for tidal stage at the time of the landfall, as well as wind and wave setup. So those details are particularly important for places with a large tidal range. As you can imagine, a storm surge from a storm making landfall at a very low tide is going to have much less impact than the same surge occurring at high tide. So here is significant wave height. We use this wave data in part to model that wave setup when calculating the storm surge results you saw earlier. And then here is cumulative rainfall. So note that all of our hazards account for surface roughness, topography, bathymetry, coastlines, etc., which is not necessarily something you can find in all sorts of databases. And of course, there's no point in displaying data that we don't feel confident in. And just like how Charlie did some verification plots with JEDI, we also did some verification plots of our data. So we verified the accuracy of our modeled data against data reported and recorded by weather stations. So for example, in this image, you can see for Hurricane Ida, the colorful polygon layers at the bottom correspond to the intensities of the wind that we modeled, and then the circles on top are the reported data from weather stations. So you can see that they match pretty closely in color, particularly near the center of the storm, which is great. And we did a similar thing with storm surge as well for Hurricane Ida on the left. And then we did additional verification using correlation plots, like on the right, where we plotted over 1,000 storm surge observations from 16 historical storms. And we found a strong correlation between our modeled and the station's reported results. Now you might have noticed there are some additional tabs on KineticCast I didn't show you just yet. And that's because you need a more intense storm to see those come into play. And so here is a demo with Hurricane Irma from September of 2017. So when a storm like Hurricane Irma is intense enough to generate big losses, additional layers become available on KineticCast. So in this case, we see loss and facility layers. Loss is economic loss in USD in terms of purchasing power parity, and can be broken down into admin levels, such as admin 0 for the national level, which can be particularly important for small countries like island nations. And there's admin 1 for the state level, and admin 2 for what is essentially the county level. Our hazards are run at about 60 arcsecond resolution for real-time data, so that's about 2 kilometers, which allows us to go into detail like this. And similar to what I showed with the hazards earlier, we did verification of the economic loss that we modeled with the reported impact and got strong correlations as well, which is great. Now, of course, economic loss does not exist in a vacuum. With a big storm, you're going to get facility impacts as well. So we show that broken down by airports, seaports, energy facilities, medical facilities, etc., both on this map and also on a separate tab in table form to give further breakdowns. And that includes, for the facility impacts, showing the start time of impact for each facility and the duration of its shutdown. Now, you might have also noticed 2 other tabs on the top, forecast quality and history. So before I show you those, remember this shape real quick that we see on the map view. So you see how things change. So Kineticast lets you see the hazards and impacts of a storm under different forecasts. So earlier we were using the National Hurricane Center's forecast to generate these hazards, but now this is from HWRF, a mathematical model guidance, and then this is from the UKM, the UK Meteorology Office. And you can always click on each layer to find out more details about that plotted layer. So that's where that forecast quality and forecast history tab come into play, because not all models perform the same for every single storm. And the forecast quality tab basically shows you how close each model's forecast was to the storm's actual track on each particular storm day. So the farther away a point is from the center of the circle, the more off, quote unquote, the forecast was for that day. And so you can see with this, which forecast model might be performing better for a particular storm. And that can help you decide which particular forecast might be worthy of being prioritized in your analysis for that storm. And the forecast history tab basically allows you to compare how all of those different forecast models did on any given storm day by just combining all of them onto one big graph. So how can we use this data in application away from that website concept? So in the past, our data has been used in asset and portfolio management and resilience, risk analysis, extreme weather event preparedness, and of course, the topic of today, emergency/disaster response. So let's take a look at that last one. So our client, PDC, Pacific Disaster Center, recently used our data in their monitoring of Super Typhoon Rai, a Category 5 hurricane in the Philippines. Unfortunately, at least 375 people died from that natural disaster. But where there was a quote unquote silver lining, the PDC Deputy Executive Director said it would be the heartening support that data like ours provided to the Philippines office. So PDC's disaster awareness system, which uses our tropical cyclone data, was handed over to the Philippines just days before the typhoon began. But that early warning and critical impact information was quickly named a milestone achievement and allowed for critical life-saving information to aid rapid response, including making swift decisions to evacuate residents, suspend work and school, ground ferry and cargo vessels, and cancel domestic flights, including in major cities with populations of 8 million people. So what's next? Kineticast, it's something we're very proud of to have been able to make with MHCat, but that doesn't mean the road ends here. With JEDI, we're excited to allow for inter-country large-scale economic data to be used and allow users and governments and all sorts of people to make more informed decisions about impacts, emergency planning, etc., the way Charlie showed. So thank you so much for tuning in, and let's create a world resilient to extreme weather events.
Thank you, Diana, for the excellent presentation and focusing in on some of the applications of the JEDI framework with the Kineticast. So we are at the end of our formal talks. Now I'm going to open up the floor for questions. If anybody has any questions for our panelists, let's see. So I've got a couple of questions to start things off with while we wait for other questions to come in. So this is a question mainly for Charlie on the JEDI scale. So we did see, some of the JEDI applications for different hazard. But the question is the JEDI scale applicable to any hazard? If so, does that mean the results from the JEDI are comparable between hazards?
That's a great question. I don't know if it's applicable to every disaster. When we think about climate change, it's really applicable towards acute rather than chronic disaster. So you can look at floods, future coastal surge risk, for example, but it doesn't do a great job with heat, for example, or drought. It's really looking at more disasters that lend themselves to quick catastrophic effects. But to your second question, yes, the disruption that we're looking at with Northridge, for example, was compatible with what we saw with Hugo. And that seems about right in terms of the cascading economic impacts.
Okay. All right. Thanks, Charlie. A second question, again, regarding the resolution of JEDI. What is the geographic scale or resolution that you're using JEDI for, and is it variable? Can it change depending on its application? What are your thoughts on that?
Now the resolution, the spatial resolution.
Correct. Geographic, yeah.
Yes, Jedi itself, the score has no spatial resolution. It's a per event score that is generated. Now, to come up with that per event score, we have to calculate impacts per sector, we use GATM level 3 county level data. So we use that data, that disaggregated Jedi score, if you will, essentially to evaluate risk, for example, for looking at TCFD and so on and so forth. You can go all the way down to the pixel level if you wanted to. It would not be valid at the pixel level, but you can use it, I think, to identify problematic areas from an economic point of view. And for that, we recommend that county is probably the best or the lowest that you'd want to go, given that this is a macro scale model.
Okay. All right. Thank you, Charlie. If there are any follow-up questions on the details of the Jedi scale, be happy to take. Next question for you, Shana, about the relationship between federal agencies. So how does NASA work with NOAA in this case?
Sure. I think we work with NOAA in a variety of ways, frankly. One major way is through NOAA being an active partner on a number of the solicitations that we have funded within the program. And so in some cases, the 10 different projects that I mentioned, NOAA is on the receiving end of the products that are being developed. And so the entire process is meant to have our sister agencies as the recipients and co-developers of these projects, so that whatever is developed is integrated into their operational systems of NOAA. And so some of the weather related projects that I mentioned and some of the flooding, as well as I think one other from the list of 10, all have NOAA as a partner. That's one way. Another way is through an active element that I'm managing now, where because of the role that I have with the management of the socioeconomic assessment portfolio at NASA, NOAA is a collaborating and co-sponsoring agency of a solicitation on socioeconomic assessments. And so together, along with our collaborating agency USGS, we are advancing the approaches to assessing the benefits of earth science information for societal benefits, right, to decision making, et cetera. And so I think there are a number of ways that we partner with NOAA. And then the final way actually is that when it comes to like the active response capability and the open science element that I mentioned earlier on in my presentation, is that we're currently actively exploring whether or not we can create a shared cloud environment to essentially, I think, act as a proving ground for early research to applications capabilities. So something that is more on the research end, but shows high opportunity or a robust opportunity to explore into operational transitions. Then, how can we create a proving ground environment to advance that? So number of opportunities, lots there. Thank you for the question.
All right, thanks, Shana. Yeah, and then I think a lot of the folks in the audience would be interested to get access to this portal, that you just mentioned. So it'll be good to share that at some point. We can follow up with email if you don't have that handy. And the next question is kind of related to that, but it's about does NASA post data for download? So I'm sure there are plenty of places that NASA hosts this data. So if you could give a quick overview, where can people access data? And I'm thinking relevant to this conversation because NASA has like tons and tons of data. So.
Yeah, I would say that probably because this is disaster theme, I'm about to put the link to the disaster portal into the chat box. That's the easiest way to find the most disaster focused and relevant data, especially I think if you're looking to access things that are already processed and formatted into like an ArcGIS type format. For those that are more advanced in how they access data, we have a variety of platforms through EarthView and others across NASA that can give you like more global data sets for a variety of elements. And so what I'll also do is put my email in the chat box as well, in case anyone would like to reach out and explore particular themes, maybe that are outside of the disasters realm.
Right. Thanks, Shana. Thanks for that. The next question is Diana. Does kinetic analysis work for other natural hazards, or is it primarily hurricanes?
So we do also work for earthquakes and wildfires, and we're working on some windstorms as well. But for the primary data that we provide, it is hurricanes.
Okay, all right. And then there's a follow-up, in terms of access, how do governments and NGOs access your forecast from
Yes.
Kinetic?
So we offer licenses to KineticCast, and we do give non-government organization discounts and things like that. So if you're interested, you can email us. I'll put an email in the chat, inquiries@kinetico.com.
Yeah, just a quick comment on that. Today's webinar, is primarily focused on an audience that are from the government and NGO sector. But there's obviously overlap with other sectors such as insurance, commercial real estate, and some of the applications that Charlie showed, perhaps made that point. But we are going to have another one, and I'll provide the dates in a second, in September, that will be primarily targeted for the insurance world. So just stay tuned for that. Okay, I think there's one other question for you, Charlie, on the JEDI. Does JEDI link with the UNISDR data on resilience scorecards? I don't know if you're familiar with the resilience scorecard, but how does that link?
Well, I'll have to look into that. That's a good opportunity to see if there's a potential tie-in. I have looked at that a long time ago, but it's not ringing a bell. I don't think that's a per event index. I think that's a community index. We do incorporate the notion of community resilience into the model, and we use FM Global resilience scores in several places in the model to try to characterize the different ways that different areas in the world tend to rebound, but we have not looked at the UN score.
Okay, let's see. All right, there is a question. Can you touch on how this work is different from the complements of other A37 projects? I think it's a question both for Shana and Charlie. Such as the flood project, in particular, the model of models. What are the tie-ins or the alignments? Anything that you'd like to share?
Yeah, maybe I should start, Shana, and you can correct me. That'd be nice if I'm wrong. Yeah, we do have the model of models is an effort that is looking at integrating different ways of modeling the extent of floods. And we do plan to integrate that into the JEDI system in order to come up with a score that we would be able to serve actually to PDC. And we've got a separate grant called GIFT in order to look at the applicability of that. I don't know if we're going to be looking at other hazards as well within that project, but it is at the research stage. We have to make sure that what the model comes up with is suitable for a JEDI type score. But in general, there's a lot of synergy between the A37s. We've worked with a lot of the different groups trying to act as a conduit to insurance, actually, or to use we're generally more exposure oriented. So that works well for others that are looking at, say, things like the extent of the hazard or platform solutions. It's a pretty good group of folks, I think. Shana, I don't know if you want to say more about that, but.
No, I think you covered it. I would say that there are a lot of approaches that are trying to not only expand how we look at, the vulnerability and exposure components, but then how we connect multiple platforms to enhance how different data can be made available to, let's say, single users, but a variety of single users. And so the model of models is one approach to doing exactly that, which I think speaks well to this idea of more integrated approaches to being able to understand, risk. And so in this case, the model of models is one element of our portfolio that's focused on flood related hazards. And so a lot of opportunity there to explore. And I would say you can reach out to either Maggie Glasgow, who posed the question, or to Charlie for more information.
Right, thanks, Shana. I think we are right a minute or so away, so I'd like to wrap this thing up. First of all, thanks to all the speakers on the call today, Shana, Charlie, Diana, for your great presentations. I'd like to also point out we have a few of these coming up. ImageCat hosts these technical webinars, data spotlights, with our partners, in the industry, as well as with, government collaborators and clients. You can see some of these dates. Yeah, there's some more information. We'll be sharing the video link pretty soon, perhaps later today. And if you have any questions, you've got Shana's, Charlie's, and Diana's, contact. Feel free to reach out. And thanks everyone for your participation, and have a nice rest of the day.
Thank you.
Thank you, Shubhru.
Thank you, everyone.
Bye.